Hey guys, we're gonna look at Geo Review number 6. It's gonna talk about a lot about coordinate geometry. So we're gonna need some formulas for this. Might need to use the slope formula. So I'll write that up there. And again, you need two coordinates for this formula. You might have to use Pythagorean theorem for distances. Okay, for the distance. And you could also use a distance formula, or you might have to use a midpoint formula, which you find the midpoint by adding the x's and the y's for the two coordinates you need, and find an average of that, so divided it by 2. So let's move on to some questions. And a lot of the same things apply that have before. Draw, label. In this case, give you coordinates. If you have some graph paper handy, use that as well. So if you look at question 1, it says the center of circle Q. So I'm going to draw a circle, label Q. If circle Q passes through R, so let's say I draw a line R. R is a point 7,1. What is the length of its diameter? So if R is on the circle, okay, then we're basically trying to figure out the diameter, and finding the distance between Q and R will give us a radius. So what we'll need to do later is double that. So what you can do, and I've been doing it this way with my students this year, it's kind of helped them. You write down the two coordinates and you find the difference between those two coordinates. Okay. So you just want to subtract bottom minus top in each case. And then since you're trying to find the length, the distance, you would take those values, and those values for x and y will go in for a and b. So that'll help you see which happens in this case. Kind of if I write it as an equation for a circle, that'll help you find the radius squared, and you take the square root of that to find the radius. So let's move on to another question. Let's take a look at question number 6. Okay. So with question 6 says equation of a line perpendicular to the line, okay, and passing through 6, -4. So, well, first thing we can talk about is, it says perpendicular. So first thing we need to figure out is the slope of that one line. Now we talked about this before. Slope is m, so slope is the value next to x. You may have to rearrange it. We have to rearrange the equation, but in this case we don't. So we know the slope of our first line is -1/2. And then to find the perpendicular slope, we have to flip the fraction, change the sign. So this would be -2/1, which would just end up being -2. So what we're going to do is we're going to take this equation. We're going to use the equation for a line. So we're going to take the point they gave us, which was 6, -4. So we're going to put the y plus 4 equals, and now m is going to be -2, because that's our new slope. Actually, sorry, I mean +2. +2. Let me change that here. Those are positive. For change the sign on that. And then you got x -6. So before I even solve any of this, I'm going to notice that, hey, a couple of these are still at -1/2, so I'm going to cross those answers out. Now I'm going to go through and see which answer I'm going to get, either C or D. So I got y plus 4 equals 2x minus 12. And then I'm going to have to subtract the 4 on each side. And that's going to give me y equals 2x, and then -12 minus 4 would be -16. So that means that D is going to be the answer. Now again, I'd want to take this equation, put it in y equals in the calculator, and see if that point is in fact on that line. Just double check it. And if it's a multiple choice, you can always double check the answers, because one of these two is going to be on that line, 6, -4. You could use that as kind of a shortcut. So let's move on to another question. Hang on. Alright, so I skipped ahead to question 17. And for this question, they want us to state the coordinates of P such that we're broken into a ratio of 2 to 3. So they give you a graph for this. It says it's optional. I'm going to show you how to do it with the graph, and I'll also show you how to do it algebraically. So first thing we're going to do is put in A and B on the graph. So we got -6, -5. So that's A, and then we got 4, 0. So I'll draw the segment for that, because it says it's the line segment in the question. So now they want us to figure out how to break this in a 2 to 3 ratio, which in other words, there's going to be 5 parts to this line, and P is going to be 2 parts of those 5 in. So what you're going to want to do is you want to find the differences for the rise and the run. So like starting at A, imagine counting up from here. You got 1, 2, 3, 4, 5. So it's 5 up, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over. So now we got 5 up and 10 over to get from A to B, which in each case, because the ratio is 2/3, we're looking to get 2/5 of the way through that line. So if you take each of those two numbers, 5 and 10, and multiply them by 2/5, that's going to give you the amount that you need to move to place the next point, which is P. So 2/5 of 5 is 2, and 2/5 of 10 is 4. So if you go up 2 and right 4, that's going to give us a location of P. So in the case of this one, up 2, right 4, this is going to be a location of P, which ends up being -2, -3. So that's the first way to do this question. Now, the other way to find it algebraically, what we need to figure out is first we're doing a dilation, and we're starting at point A. So A was -6, -5. Now we did figure out that our dilation is based on the fraction 2/5. So that's K, that's our scale factor. So if you want to do it algebraically, what you're going to have to do to set up the coordinate for that, you take the first values, the -6 and the -5, and then what you're going to do is you're going to add that to the scale factors, and then in the parentheses, you're going to put the run and the rise. So like for the -6, that's the x value, so it ran 10, and for the run it's 5. So if you put each of these two expressions in the calculator, that part separately and that part separately, you're going to get that answer that we just talked about, which was -2, -3. Okay, so that would be point P. And again, it says the graph's optional. The graph can be helpful, at least for purposes of checking, if you don't use it exclusively for the answer, because I know a lot of people like the visuals more than trying to do it algebraically. But if you do it both ways, even better. Okay? So I hope that helps you with these. And again, like we talked about, the formulas at the beginning, parallel slopes being the same, perpendicular slopes being a flipped fraction in the opposite sign. And then also there's always questions on the Regents dealing with partitions and breaking segments and finding points on segments.